Hi there, Pre-Calc gang. Time for lesson 7.3, the sum and difference identities. This is a pretty famous identity or series of identities that we're going to learn about today, and it is accompanied by a famous chant or cheer that will help you remember them. All right, here we go. Now, one might think that if I had the sine of 30 plus 60 like this, it would equal the sine of 30 plus the sine of 60. Seems reasonable, correct? Well, let's just sort of check this out and see what we can come up with here. So this obviously does mean the sine of 90. Ooh, that's pretty skinny there. Let me erase that and check my pen width here. All right. So clearly this would be the sine of 90 degrees if I add those up, right? And we know that the sine of 90 is 1. Well, it should be the same when I look on the other side, correct? Well, the sine of 30, if I visualize what that is, that's going to be 1/2. You can look on your circle chart to verify this. And the sine of 60 would be the square root of 3 over 2. And I think you can pretty much see that 1/2 plus the square root of 3 over 2 is not going to be equal to 1 that we found over on this side. So the idea is then that the sum and difference identities will be much more than just applying the distributive property to our angles that we know of. I'm going to actually show you what these sum and difference identities are. Here they are. They are on the back of your circle chart, of course. Just have to add one more thing to these. Notice this plus or minus, that's fairly significant, and especially the order that they occur. So on the sign of plus or minus b, if there's a plus sign in there, there's also a plus sign in the expansion of it. Now with cosine it's a little different, because if there's a plus or minus here, in the expansion then it will actually be the opposite sign. So I'm going to put minus plus. And the same thing with this tangent one as well. On the denominator anyway should be a minus and a plus like that. So take a little bit of time and write these down, and then we'll show you actually how they work and show you this little chant anyway for the sine and cosine ones. Alright, here we go, and assisted by our Buccaneer cheerleaders, of which we may have at least one in one of our classes anyway. So here we go. You can kind of follow along with the bouncing red ball here. And we'll do this a couple times. We'll, of course, also do this in class because there are some clapping and stuff like that that goes along with it. All right, here we go. Sum and difference identity cheer with sine and cosine. Ready, go. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Not too tough, right? Let's try it one more time, this time with a little bit more volume and expression. 1, 2, ready, go. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. So that's an easy way to help you remember these. Now let's actually see how they work in real life as far as the problems that we solve go. All right. Now the whole purpose behind these is that you can find the exact value of some of these things. Now you can obviously put the cosine of 75 degrees in your calculator. You'll get a very precise answer, but it's not the exact answer. So how we're going to do this is we need to find on your circle chart a couple angles that would either add or subtract together to give you 75 degrees. And so I think probably the most obvious ones are 45 and 30. So I can write it like this: cosine of 45 plus 30. And then I just use the formula that I just stated or cheered or chanted back there. And I remember that the cosine expansion is cosine cosine. So cosine 45, I'm not putting the degree signs here. Cosine 30. Now the deal with cosine is that that sign in the middle is the opposite of what it started with originally. So then this will be minus sine 45 sine 30. And then you simply use your circle chart to fill in the exact values of these particular trig functions. So you remember that the cosine of 45 is the square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2. Got my minus sign in there. Sine of 45 is that square root of 2 over 2. And the sine of 30 is 1/2. I can do a little bit of multiplying here with those two terms, and sure enough my answer ends up to be the square root of 6. I can multiply those numbers together underneath the square root over 4 minus the square root of 2 over 4, and if you want to be really fancy you can just write it as the square root of 6 minus the square root of 2, all of that over 4. That's the exact value of the cosine of 75 degrees using a trigonometric addition formula in this case. Keep in mind you can use any either a subtraction or an addition expression as long as the two values in here either add or subtract to 75. So there are several other possibilities in addition to 45 and 30. Kind of an example here. This one is not as specific, but this says we want to try to find the value of the sine of x plus y given these conditions. Basically all this means is that x is in the first quadrant and y is in the second quadrant. Now they actually give you a couple of angles there, x and y, so let's see how these work. So let's, I think a good strategy for these kind is to draw some little right triangles. We're going to call this angle x, and so it tells us that the sine of this is 4/5. So you might remember that sine is opposite over hypotenuse. And by the way, then this other missing side would have to be 3, 3, 4, 5 right triangle. And then, let's see, I'll try this color here. Then I'm going to have another angle which we'll call y. And notice it says the sine of y is 5/13. Sine, of course, is opposite over hypotenuse. I can do a little Pythagorean theorem or just remember that this other side here is going to be 12. Now I'm just going to expand out the sine formula here. So that sine of x plus y will be the sine of x cosine of y plus, notice that the signage is the same when we expand this out, cosine of x and sine of y. Now I simply look on my triangles here and fill in the appropriate values. And an important thing to consider is, since both x and y are in the first quadrant, I know that all my answers will be positive. That won't always happen as we look at some other examples, especially in your assignment. Anyway, the sine of x, sine opposite over hypotenuse, so that's going to be 4/5. Cosine of y, now I got to move over to the other triangle. Cosine of y is going to be adjacent over hypotenuse, so that's 12/13. Plus sign in the middle, and then I try it again. The cosine of x, well, the cosine of x is going to be 3/5, adjacent over hypotenuse, and the sine of y should be 5/13. So if I multiply these fractions, not much can be reduced here. 4 times 12 is 48 over 65, plus 3 times 5 is 15 over 65. Add those up and it looks like you'll get 63 over 65. That's sine of x plus y with these certain conditions. Again, we have to expand out that formula, fill in the correct values for the sines and cosines, and then simply evaluate. Probably do a tangent one. This one's a little bit unusual, so we'll see what we can do here. The other strange part about this is the pi divided by 12. Now that's kind of odd for us until we realize that pi over 12, we can write that as, anytime you see pi, remember that's 180 degrees. So 180 divided by 12, that's 15. So really this problem is just asking for the tangent of 15 degrees. Again, we're going to try to find some combination of angles on our circle chart that might add or subtract to 15. I am just going to say that this is going to be equivalent. We'll try this, the tangent of 60 minus 45. And we'll see if we can expand this. Now the tangent formula is the trickiest one to remember. So we'll just look back in your notes or circle chart card and see if we can do it. So we got the tangent of 60. And again, be careful here. If the sign is a minus sign in the middle here, it's going to be the same sign on top but different on the bottom. So this is going to be the tangent of 60 minus the tangent of 45. All of that over 1 plus the tangent of 60 and tangent of 45. Now let's try to simplify this a bit. If you look on your circle chart, you should know these various tangent formulas here. So the tangent of 60 degrees is the square root of 3, I believe. Tangent of 45 is just 1. That's a nice number. And tangent of 60 times the tangent of 45. So basically, square root of 3 times 1 right there. So I'm simplified down to the square root of 3 minus 1 over 1 plus the square root of 3. Now that's an okay answer, not fully simplified. I think since I'm running out of time a little bit, I'll let you try to work on that. You'd have to multiply by the conjugate of this to get your final answer, which I believe should be 2 plus the square root of 3. Thanks for listening, everybody. We'll practice on these, of course, in class tomorrow, and see you then.